Okay, so what we want to do is we specifically want to use curl and stuff like that to find if this field is conservative, right? What we've been doing is we kind of just been doing this is dp dy equal to dq dx. If that's true, then say f is conservative, right? That's what we've been doing so far. But we want to use a different tool. We want to use a better tool. And notice that we have three. We have P, Q, and R, right? We have this is P, Q, and R. So we have three components. So this wouldn't even really work that well, right? So we kind of do have to use curl, right? So theorem is, right, if curl of f equals 0, then what? If the curl of f equals 0, then it means f is conservative. Okay? F is conservative. And if f is conservative, then there's some little f, right? Some little f, and you take the gradient of it, and then it's equal to f. So there'll be a lot of things we're going to do here, but let's start by taking the curl. So curl is equal to the gradient cross f. So the gradient cross f, in this case, we could write it, let's write this determinant, dx, dy, dz, and we're going to put in here all this stuff, but let's write it as p, q, and r right now. P, q, and r. So we're going to write it as p, q, and r, and we're going to put this stuff in. What we're going to do is we're going to do this cross product thing like we always do, but we're going to apply a derivative with respect to y to r. Okay, so if we write this out, and I'll write this out in a, this is going to be a vector, it's a vector product, right? Cross product produces a vector product, and I'm going to use the column vector to describe this. dy r, so dy r minus what? dzq. dz(q), then it goes dxr, don't forget the negative though in front of it all, dxr minus dzp, okay, and then we go dxq, then minus dyp, and notice real quick, let's make a little thing right here. This would be q with respect to x minus p with respect to y, and that is what, you see that a lot in Green's theorem, right? You see that in Green's theorem, so just remember that that's where the Green's theorem comes from. Nonetheless, let's actually do this math here. So, okay, so what we want to do now is we actually want to carry out this math, so let's do that. R with respect to y, what's its derivative? It's negative x sine y. Then we're going to minus q with respect to z, which is x sine y. So negative, negative, okay. Okay, now we got to take r with respect to x, okay? So r with respect to x, right here, will be cosine y. And p with respect to z is going to be minus cosine y. So these cancel. This does not cancel. Okay, so we already know f is not equal to 0. We know that for a fact because these don't cancel. So we could actually stop there. We should stop there. If f is not equal to 0, then f is not conservative. Then the field is not conservative. Right? So if f does not equal 0, then I'll go dot dot dot. F is not what? It's not conservative. That's your answer. That logic is true, right? There we go.
Consider subscribing and liking if you found this video interesting or helpful. Leave a comment. Just leave any comment, just so I could, get this video pushed up the algorithm.